In this video, we're going to learn about logarithmic and exponential derivative rules. Okay, so logarithmic and exponential. So we'll start with logarithmic. So let's say our function is ln of x. Then the derivative is 1 over x. Okay, so let's look at a graph of ln of x. So remember, ln of x passes through 0 at x equals 1, and it comes like this, and levels off. So below it, we'll graph f prime of x. If f prime of x is 1 over x, that looks like this, right? Oops. Right, there's also a curve down here, but since ln of x is only defined for x greater than or equal to 0, we only draw the right-hand side of 1 over x. If there's no function on the left, there's no derivative on the left. Okay? Now let's draw some tangent lines on ln of x. So starting out here, the slopes are very large, right? Large and positive. So that would be a point on the derivative curve over here, large and positive, right? And here we have a slope that looks like a 45-degree angle. So that would be about 1, right? That would be closer over here. So imagine dropping these points down. And then out here, the slopes level off and they get closer to 0. Okay, so that's what happens to 1 over x. It levels off and it gets closer to 0. What's the limit as x goes to infinity of 1 over x? 0, right? That's what's happening to the slopes of ln of x. They level off as x goes to infinity. Okay? So let's look at exponential. F of x equals e to the x. F prime of x is also equal to e to the x. It's the same thing. F of x is equal to f prime of x. This is the only function that this is true for, aside from f of x equals 0, right? It's pretty interesting. Function equals its own derivative. So let's look at a graph of e to the x. Okay, so e to the x starts off very small, and it increases very rapidly as x is larger than 0, right? And if we think about the slopes, first I'll just draw in the derivative down here. So let's draw in some slopes. Here, the slope is pretty flat, right? Close to 0. And then as x gets larger, the slopes increase. And they increase without bound. They'll never stop at some asymptote. They get more and more vertical. Right? So if we drop these down, this is close to 0, this value is close to 0. Right? And then as these points get larger in x, or as the x value increases, the slopes get larger and larger. Right? So that's the intuition behind why the derivative of e to the x is equal to e to the x. The slopes of e to the x get larger and larger, just like e to the x. Okay?